Hi students, I am going to start exercise 6.7 introduction video. The introduction part topic equation of a plane passing through the three given non-collinear points. Three given non-collinear points of equation of the plane. Okay. So now the first condition, parametric form of vector equation. Parametric form of vector equation. Definition: if three non-collinear points with position vectors a vector, b vector and c vector are given, then the vector equation of the plane passing through the given point in parametric form is r vector equal to a vector plus s into b minus a, b vector minus a vector plus t into c vector minus a vector. Okay, where b vector is not equal to 0 and c vector is not equal to 0 and s comma t belongs to r means is a real number. And non-parametric form of vector equation, the box of r vector minus a vector, b vector minus a vector, c vector minus a vector equal to 0. And a Cartesian form of equations, the 3 points are now x minus x1, y minus y1, z minus z1 and x2 minus x1, y2 minus y1, z2 minus z1 and x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. The determinant value of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Okay. And next, equation of a plane passing through the given point and parallel to two given non-parallel vectors. Okay, so now in this point of 1 point and 2 vectors, 1 point are 2 vectors given a point and parallel to 2 given non-parallel vectors. Okay, the first subdivision, parametric form of vector equation. The parametric form of vector equation, r vector equal to a vector plus s b vector plus t c vector, where s comma t belongs to r. Okay, and non-parametric form of vector equation is r vector minus a vector dot b vector cross c vector. R vector minus a vector dot b vector cross c vector equal to 0. And a Cartesian form of the equations, x minus x1, y minus y1, z minus z1 is a x1, y1, z1 is a point of the value, and b1, b2, b3 and c1, c2, c3 is a vector point. Okay, so the determinant of x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3 equal to 0. And next one, equation of a plane passing through the two given distinct points and parallel to a non-zero vector. 2 points and 1 vector. The parametric form of vector equations, r vector equal to a vector plus s into b vector minus a vector plus t c vector, or r vector equal to 1 minus s into a vector plus s b vector plus t c vector. S comma t belongs to r means real number. Then the non-parametric form of vector equation says r vector minus a vector dot B vector minus A vector cross C vector equal to 0. And the Cartesian form of the equations x1 y1 z1 is a point and x2 y2 z2 is the point, and c1 c2 c3 is a vector. Therefore the Cartesian form of the equations the determinant of x minus x1 y minus y1 z minus z1 x2 minus x1 y2 minus y1 z2 minus z1 c1 c2 c3 equal to 0. Okay, that's all. We will meet the next class.